Hi everyone, welcome back. Let's see another variation of FCFS algorithm. And the mode will be non-preemptive mode and the arrival time is the criteria. Guys, in general, if you observe the life cycle of a process, generally process which are ready to run will be available in the ready state. CPU scheduling algorithm will apply and it will enter into the running state. Right? Then, while it is in the running state, there might be a chance to satisfy the request of IO request. The process will come out and will enter into waiting state, or I can call it as block state. Once it completes the waiting state or block state, again it will enter into the ready state. Then, after getting the chance, it will be allocated to again to run it. Right? So, which means that once it got a chance to run, that is what we call as burst time. Then after requesting for IO process, it is in the block state, that is what IO time, and then again it will enter into the ready state. Later part again it will enter into the burst mode, which we can call it as a running state, right? So which means that a process can have n burst times as well as n IO times, right? Until it satisfies the requirement, or I can say n by 2 burst times and n by 2 IO times. Until it satisfies the requirement, it is going to do all these two things compulsory, right? So based on the concept, they have given here a data set. What the data set contains? Process ID, arrival times, burst time, followed by IO time, followed by burst time, which means that what? Process ID 1 arrived at the time interval of 0 and then allocated the CPU for 2 units of time, and then it exits the CPU and in the waiting state for 2 units to complete the IO process. Again it got the chance to execute the CPU for 3 units of time. This is what you have to understood with this particular example, right? So finally they are asking for what is the scheduling length, right? So you can able to calculate various kind of questions once you are able to understand the concept. So I will try to solve this one with a Gantt chart, right? So let me take CPU, which is starts with 0 nanoseconds. Guys, at 0 nanoseconds, is there any process arrived? Yes. Process P1 is arrived at 0 nanoseconds. I will try to write this as P1, P2, P3, P4, P5 to avoid the confusion. And then once it got the chance, it is going to enter into CPU mode and it will execute for how many units of time? 2 units. So 2 units completed, then it will enter into IO mode. It will enter into IO mode. So 2 units completed, then it will enter into IO mode, which means once 2 units is done, it will be available after 4 units. That is what you have to understood. After 4 units only P1 is available. You have to make sure to understood that, right? So meanwhile it is doing the IO process. As 2 units completed, is there any process available? Yes, P2 is available. So P2 will get the chance. For how much time? 1 minute. That will be 3. Right? Is there any process which is readily available at 3 units of time? Yes. P3 is available. At the same time, is there any process which come back after completion of IO? No. It is available after 4 units. So I can say P3 will be entered into the CPU mode. And it execute for how much time? 1 unit of time. That means it is 4. But if you observe, P2 will be available after what time? After completing 3 units of IO operation. So you have to make sure to note down everything. So it went for IO operation. After 3 units means it will be 6 units. After 6 units it is going to definitely available. And P3 is done with the burst time and it is going for again IO operation. And it will be available after what? How many minutes? 40 minutes. Why 40 minutes? Right now 4 units of time is there and IO operation requires 10 units. So after 4 units, 14 units, P3 will be available for you, right? Yes. But if you observe, to 4 units of time. What are the processors available for us? One will be P4, another one will be this P1. Am I right? It is because process P1 completed the burst mode and IO operation by this time. Right? So which one will give the chance? P1 will give the chance because it is arrived at 0th time. So P1 will give chance and will complete its burst time. What is that burst time? 3 units. So that is 7. So this was done completely. By the time of 7 units, P5 is also readily available. And P2 also completed 6 units of time. So what I can say now, which one will give the chance to now? We have to give either P2 or P4 or P5. You know which one will give? Will give for P2. It is because of P2 is earlier arrived compared to all other processes. So it requires how much amount of burst time? 2 units, that will be 9. So P2 also done. P2 also done. Now by the time of 9 units, is there any process is done? Yes. P4 and P5 are available, but P3 is available at what time? 14 units. So P4 arrival time is 4, so I will give chance to P4. So burst time is what? 5 minutes. So 9 plus 5, 14. So 14 minutes of time done. And immediately is there an IO operation is there? No, 0 units of time. So it will continue its execution. That means P4. So to understand clearly, I am writing continuous to only 60 units of time, right? As is FCFS, it will complete directly 16 units. By the time of completion of 16 units, what are the processes available for us? One is P5, one will be P5, another one will be P3, because P3 completion time will be 14 units. So by the time of 14 units only it will be available. Now which one will get the chance? P3 will get a chance to complete. So how much amount of time it required? 1 unit, that is 17. Good. And P4 also done, right, already. Now it will be allocated to P5. P5. So P5 requires burst time is what? 3 units. That is 20. Right? Yes. And understood that IO operation is required. So which means that here it will went for IO operation for 3 units. So means it will come back by 23 units of time. So is there any processor available now? No. Which means that CPU will be idle for the next 3 units of time until one process will be available, right? After 23 units of time, the process P5 is available, so that will be allocated again for the process P5. So burst time will be 3 units, that will be 26, right? So this is the Gantt chart for the given data set, right? Now can you able to calculate the efficiency of this CPU efficiency or CPU utilization? We can say CPU utilization, that is 26 units are allocated for the CPU usage. Out of this 26 units, how much amount of memory, how much amount of CPU you have not utilized? 3 units, which means remaining 23 units you have utilized or not? 23 by 26 into 100%. And inefficiency is 3 by 26 into 100%. Hope you understood this video clearly, guys.